Hello, I'm Dr. Revathi, Associate Professor in Physics. I'm going to teach the Advanced Engineering Physics for first BTech students. Now I'm going to talk about the quantum computing. I'm working in Marri Laxman Reddy Institute of Technology and Management. Why we need to bother about the quantum computing? Why not for the classical computers? The main reason is, first of all, we need to learn about the Moore's law. The answer for bothering about the quantum computing is the Moore's law. So what is this Moore's law? This is not the natural law. This is the law predicted by the Gordon Moore. He is the Intel co-founder. What he predicted is, he predicted that the number of transistors is going to increase or doubled for every 2 years in an integrated circuit. That means that here, so if you go from the 5 generations of computers, we have 5 generations of computers. In first generations of computer, we are using the vacuum technology is a hardware component. So in this vacuum technology, here we are getting the lot of heat is reduced, and this is going to occupy the large rooms. And we are, for first generation computer, the time period is about the from 1940s to up to 1950. Everyone, we are using the first generation computer. Later, we are upgraded the things to reduce the size and heat to get the more performance for the devices. So that's why we are going for the second generation computers. In second generation computers, instead of vacuum technology, we are using the transistor based technology. So all these are the semiconductors devices. Okay, that means transistor means this is the 3 terminal device. So here we are using the hardware computers components only with the help of the transistors. So this generation computers, we are the time period is from 1950 to 1960s. Only 10 years we are in the time period of these 10 years, we use the hardware component of the transistor technology. This transistor technology we are going to call as in a second generation computers. And after this, again we started to do research. Until now, we are not stopping the research for finding the new things and new technologies. That means we are updated and we are upgrading the things in a novel way, in a modern, with the help of the modern technologies. So after this, we are going for the third generation computers. In this third generation computers, we are using the IC based hardware components. This IC based means integrated circuits. Here the Gordon Moore also predicted that in this integrated circuit, so the number of transistors, not only transistors, we can say the semiconductor device, whatever it may be, either it is the diodes or the transistors, so it is going to be doubled for every 2 years, but the size is not going to be increases. Within that size only, the components are going to be increases. What it means? The components are increases means here the size of the component is decreases. So component size is decreases. So this is the third generation technology. This is also from 1960 to 1970, 10 years. If you observe that for every generation, only 10 years. After 10 years, the scientists come with the new ideas and new software technologies. So later, now the fourth generation computers. In fourth generation computers, we are using the hardware component as a microprocessor based hardware components. This is from 1970s to present. In present also, we are using the microprocessor technology in the computers. And now the fifth generation is nowadays we are using the word very regularly, the AI, that means artificial intelligence. Okay, this is the hardware for the fifth generation computer for future also. This is our classical computers hardware components, and based on the hardware components, we are going to divide this computer technology into different generations: first generation, second generation, third generation, fourth generation, and the fifth generation. Okay, so if you see, for one example I will show you. If you see here, So, for example, with the help of the vacuum technology, we have very long, in long rooms we are maintaining, and the heat also producing very high. Due to this problem, we are searching for a new thing, and that new thing is we are replacing this vacuum tube for with the help of the transistors. Even with the transistor also, we are thinking that the size is some level big. That's why we are going to replace these transistors with the help of the integrated circuit. Integrated means all the semiconductor components we are going to place in one device. That's why we are going to call as an integrated circuits. And the next one we are using the microprocessor. And the last one, that is now and also future, it is the artificial intelligence based technology. If you observed in our with the help of our computers also, our computer just architect. So in earlier days we are using the desktops means our computer with the CPU. Later this desktop is replaced with our laptops, and next we are replacing with this laptop with the tablet, now mobile. So if you see the size of our device, the screening device is going to reduce, but the performance is going to be increases due to the technology. They are upgrading this technology, and they are updated the technology. So this is our 5th-generation computers. So what is more predicted that for every 2 years the transistors or the semiconductor devices is going to be doubled in the integrated circuit. In one integrated chip, the number of transistors or the number of semiconductor devices is going to be doubled. And what he thought, that you can see here the another diagram. See here how we can see here. In x-axis, if you see the year, in y-axis, if you see the number of transistors placed on an integrated circuit. This is the law predicted by the Moore. This is not the natural law. So here if you see 10 power 1 to 10 power 8. So in early 1960s, okay, in early 1960s, how many semiconductor devices are there in my IC chip means 10. So if the years are going on, passing on, so up to 2020, if you say, just consider as in a 2020, so the number of semiconductor devices is going to be increased in one IC chip, that is 10 power 8. It is not the small number, it is a big number. So if the number of the transistors is increases means, if you see here from 1950 to up to 2020, the size is going to be reduced from centimeters to the nanometers. That means here we already reaches the atomic level. So that here nano level means this is an atomic level. So here the quantum mechanical rules are coming to the picture. So we can't avoid these quantum mechanical pictures. This one we can say that the quantum tunneling is going to be happened here. That means here if you take so for example, this is in a bench B and this is in a bench this is a bench A and this is a bench B. So here, for example, the actual capacity of this bench is 3 transistors, and here also the 3 transistors. If you just reduce this gap, how many we can place? 1, 2, 3, and extra here also we can place. Here also, that means we can place, instead of 6, we can place 7. In the same way, now we can also reduce this place also. Maybe we can place 8. So if you okay, what is going to be happen? This last person is going to share these 2 places. That means that properties of the transistor in A is going to transfer into the B chip. That means the transistor properties are going to be tunneled from A to the B. That means we can't avoid this property. This one we can say that the quantum mechanical properties are coming to the picture. That's why we can say that now from classical computers to we are going to move towards the quantum computers. That is the reason. So according to the Moore, he said that the number of transistors on a microchip is going to be double for every 2 years. That means here up to 2020 we already hit the quantum level. That means the size is going to be reduced. If you still reduce the size of the transistor, so what is going to be happen? The properties of these charge carriers, whatever it may be, it is going to be tunnel from one transistor to the another transistor. If it is like that, we can't predict the same classical mechanical rules. We can't apply the classical mechanical rules because this is here we are seeing the quantum mechanical picture. That's why we are moving towards the quantum computing. So then, so if the Moore's law is going, so we can't say it is not going to be end. The next alternative is the quantum computer, because for in present so the number of transistor per chip is 10 power 8. And the size of the chip is typically 100 nanometers. This means, so for storing in a single bit of information, so we already reached the atomic level. So if it is reached the atomic level, so then quantum effects becomes unavoidable. That is, we are going to move towards the quantum computing. So this is the main reason why we are going from the classical computers to the quantum computers. What is a quantum computer? So what is this in the brief history? So a quantum computer is a machine which is going to perform the calculations with the help of the quantum mechanical principles. So with the help of the quantum mechanical principles, we are going to perform the calculations on a computer. So here, if you see here the main principle of a quantum computing is the superposition and quantum entanglement. These are the two main principles we can say. Even interference also we can say. But this superposition and entanglement is the one major principles used in the quantum computing with the help of the quantum mechanical properties. So here if you see that in classical computers, we say that the information is going to store in terms of the bit. Here the bit means 0 and 1. Whereas in quantum computers, here we can say that the quantum bit. Here we can say that the quantum bit. The quantum bit means here 0, 1 and superposition of 0 and 1. This linear combination of the 0 and 1 we are going to call as a quantum bits. This quantum bits means here we are going to say that the state of a subatomical particle. Where is in a subatomical particle? Either it is in a 0 state or 1 state or in superposition state. What are the subatomic particles? The subatomic particles are either electrons, protons or phonons or photons. Okay. So here if you remember that the 0 and 1 and superposition means these are the states of the subatomic particle. Where is our subatomic? Where is the state? Is it in 0 state? Is it in 1 state? Or is it in the superposition state? Okay. With the help of this quantum computing, we are going to get the fastest calculation. For example, if you need to do a one complex problem with the help of a classical computer, it is going to take the 5 days. But with the help of the quantum computers, we are going to get this complex problem solution within 2 minutes. How fast it is going to give the calculations. So the main principles here is the quantum mechanical principles, and majorly here we are using the quantum superposition and the quantum entanglement. Okay. So next, if you see here, this is the hardware component of the quantum computers. And here there is the more number of advantages of the quantum computers when compared to the classical computers. Okay, in next class we can explain more detail about all these things in classical, what is the classical computer values and what are the difference between the classical computers and the quantum computers. Okay, if you need, you can see the references. Okay? Thank you.